Hello, everyone. This is Mr. Lichtenberger again. We are going to start Algebra 2B today, the second semester of Algebra 2. So, to start Algebra 2B, we will start with the second half of Unit 4. You might remember at the end of last semester, we left off with the first half of Unit 4. So, we're going to start the second half of Unit 4, which is starts with Lesson 8. So there are no new lesson notes in this particular lesson. So I'm going to get right into the examples for this lesson. So here is a pattern showing a trapezoid being successfully decomposed into four similar trapezoids at each step. If n is the step number, how many of the smallest trapezoids are there when n is 4? What about when n is 10? So let's first look at the pattern here. So we start with one trapezoid, then we go to 1, 2, 3, 4 trapezoids. Then we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So it would appear that we are quadrupling each time. So if I were to create an equation going back to our exponential growth from the very end of last semester, all right, we would use our y equals a times b to the x. My initial value would be 1, and my growth factor in this case would be 4, since I'm multiplying by 4 each time. So it would be 4 to the power of x, or in this case, it says to use n as the step number. So it would be 1 times 4 to the power of n. And in fact, because my initial value is 1, I really don't need to write n, because 1 times anything is itself. So my equation is going to be 4 to the power of n. So to answer number 1, when n is equal to 4, I'm just going to do 4 to the power of 4. And when n is equal to 10, I'm going to do 4 to the power of 10. So to calculate that, I'm just going to go on Desmos and do that really quick. So 4 to the power of 4 and 4 to the power of 10. There's my answer. So when n equals 4, there'll be 256 trapezoids. Okay. And at 4 to the power of 10, at step 10, it'll be 1,048,576. So 1,048,576. So there's your answer to number 1. Number 2, at a certain step, there are 262,144 smallest trapezoids. Write an equation to represent the relationship between n and the number of trapezoids in that step. So in this case, we don't know the step number, so we don't know the n value, but we do know that the answer is going to be 262,144. So to write an equation, this right here is the equation. 4 to the power of n equals 262,144. So that's the equation. B, explain to a partner how you might find the value of that step number. Now, we haven't learned a way of figuring out what this exponent value is. So the only way we could possibly do that is to guess and check using Desmos. So that's how I would explain it right now. So we're going to guess and check using Desmos. I already know the answer has to be between 4 and 10, because at step 4, it was at 256, and at step 10, we were already over 1,000,000. So the 262,000, that's going to be somewhere between that. So let's go on Desmos and let's actually figure out what the answer is. So let's try 4 to the power of 5. Nope. 6. Nope. 7. Nope. How about 8? No. So that leaves only one possible answer. So that would be step 9. After 9 steps, there are 262,144 trapezoids. So the value of the step number would be n equals 9. How did I find that? I guessed and checked using Desmos. Throughout the rest of this unit, we're actually going to learn mathematically how we can figure out exactly how we can figure out that n equals 9 without having to guess and check. And that is it for your first lesson of Algebra 2B.